Hello, everybody. This is a quick video to run you through what you're going to be doing for the 7th lab that will be due the week after next. Um, this lab does start with a couple of questions about what superposition and Fourier's theorem are. These are basically just the definitions. So uh, if you remember, this was in chapter 4, and superposition was even earlier. So you can go reference those things, and you're basically just giving a textbook definition of both of those things. It looks a little weird on the screen, probably because I'm using the web version of Word and it sometimes messes with the formatting, but we'll get you through this. So first of all, the exercise you're using is the Fourier lab, which is called Making Waves. I have this open in another tab here. I haven't actually downloaded it. This is one of the ones that requires Java. So if you are having issues accessing that, it's probably not the best time since everything is shut down. The campus computer labs are not available. And many libraries and such are also closed. So it's understandable if you're having an issue finding a computer that can run this. Just reach out as soon as you can and let me know, so that way we can work around that. Because this one is pretty short. You'll see when I get into the meat of it, you'll probably be done pretty rapidly with this one. And so if you have a technology issue where you can't get it done, you can come back to it later on once you have the ability to do that. So I'm going to go ahead and click on this. It's going to download the Fourier Java file in Chrome. It's down here wherever you need to open it. It'll run as long as you have Java on the computer you're working with. And when we open up, we've got a couple of things. We're going to work with the discrete tab and the wave game tab later on at the very end. So at the top, you've got these amplitudes. This is telling you what harmonics are present and in what amplitude. Down below, the next graph is a harmonic graph here. This is showing all the harmonics that are present, and you can see since my amplitude for A1 here is 1, my amplitude for my sine wave that you see here is also 1. If I were to create a second harmonic here of some amount, now I've got the second harmonic showing. It's smaller because I'm only at 0.41. And then down at the very, very bottom, there is a sum wave where it's basically just doing the superposition of these two harmonics and showing you the result. So let me switch back over to the lab and we'll get kind of going through what you're going to actually be doing with this. So the first thing that it asks you to do is what happens when you change the amplitude. So coming back to my Java window here, it basically just wants you to describe how changing these different things, and it doesn't matter how you change them, changes what you see on the harmonics graph and what you see on the sum graph. As you add some of these things in, you'll probably have to resize some of these so that you can see what's going on. Pretty simple explanation there that it's looking for. So next thing it asks you to do is use the wavelength tool. So I'm going to reset this. So we've just got the one sine wave. The wavelength tool is over here. And so what it does is it shows you where a single wavelength lies for this wave. You can notice I can put it crest to crest there and see that. So now if I add in, say, I don't know, A5, I can come over to the wavelength tool and do lambda 5. And you can see here that that will measure that one. Now, this is much smaller than this. Here's 1, 2, 3, 4, 5 lambda for lambda 5 in the wavelength that you have for lambda 1. So essentially, it just asks how you define wavelength, which is something you should just remember from general wave stuff. It asks if the amplitude depends on the wavelength. So coming back to this, putting this tool back on here, you'll notice that as I switch this around, these things don't change. The lambda is not defined by the amplitude at all. Now, the other thing we can do is, in this same simulation, change from a function of space here to a function of time. So if I change to a function of time, you'll notice that the wavelength tool disappeared. There's not really any super obvious changes other than the fact that my x-axis, instead of being position when I'm doing space, which is x, is now time. So the units are different. The variable we're looking at is different. The graphs look basically identical, but we're looking at time instead of distance now. And so the wavelength tool that I had checked before is gone because I'm not measuring distance anymore. I'm actually measuring time. But I can add a period tool now, which can be used very similar to the wavelength tool. It's just telling me the time between, say, crests there for T1 and the time between crests here for T5. So the tools operate very similarly, but wavelength is giving you the physical size of the waves, and the period tool is giving you the time between crests. Also, I can, again, play with the zoom here so you can see what kind of wave I've got with these two things in there. All right. So it asks you how the periods of the different harmonics are related. And then the last thing we're going to do is change sine to cosine, and then we'll actually do a couple of really minor exercises with this. So changing the function from sine to cosine, when it's got sine here, you'll notice at the origin we've got 0, and the graph is sloping upward. If I switch to cosine, now at 0, I'm starting at the amplitude, and it will start by sloping downward. So in this case, it doesn't really change much of anything. It just kind of shifts where the axis is. If I were looking at something that was maybe not quite as random as what I had put there. So now if I change from sine to cosine for the triangle wave, again, it's really just shifting the position that we have here. So there's not a drastic change in what goes on. If I look at space, it does the exact same thing in this case. Though sometimes, depending on what your different amplitudes are, it will do more than just shift it. It might actually change the shape just a little bit. So next we are going to look at those select functions. And then we are going to change the number of harmonics that are present. So coming back to this again, I'll keep the triangle wave that I have here. So if I decrease the number of harmonics, if I just start with a sine wave, well, I have a sine wave. It doesn't look like a triangle wave at all. Adding the second harmonic does nothing because there is no second harmonic in a triangle wave. Coming into the third harmonic, there's a little bit of a yellow guy here, which might be hard to see. But now you can see that sine wave. This is quite a bit straighter, and this peak, instead of being nice and gentle, is now starting to kind of sharpen up a bit. And as I go more and more harmonics, say I go up to 9, now I'm almost at a perfect triangle wave. Even going to 11 will help just a little bit more. What we would compare here is this checkbox has a gray line that shows up that shows you what an ideal version of this function would be. And so you can see here, it's actually pretty darn close for this triangle wave. A sawtooth wave, however, you can see there's still a bit of difference. You have the general shape to the upward sloping line, but there's still a little bit of waviness to that. And you don't have this perfect straight up and down transition that you have normally in a sawtooth wave. So the last couple of things in this lab, it asks you to replicate this screen that you see for the harmonics here, and it's a space graph. So you're going to play with the amplitudes to match this. So I'm just going to make a random one with a couple of harmonics just to give you a little hint on which ones you will be working with, and then tell you what I expect you to do. Because normally, if you were doing this on paper, you could then just sketch what you see. But in this case, that's not going to work quite as well since you're doing a physical upload, unless you were wanting to like print out your version and scan it or something like that, which I'm trying to avoid because it makes it easier just to work with a standard file format when grading this stuff online. So coming back into this, we will go ahead and reset this again just so that we're working with this. So I'm going to just say work with a couple of these. You can see you already know by the colors that I have the right waves. So you're going to play with both of these controls until you get something that looks like what you have on the screen there. And these are not the right values right now. So once you have that, what you'll put in your report, just tell me the values for the amplitudes. You don't need to worry about sketching these bar graphs. Just tell me A1 is this, A2 is this. And then in the sum graph, just kind of describe in general the shape that you're seeing for one wavelength. So it starts at 0 here. It comes up to a value of whatever that is. I don't know what that is given the scale. Then it comes down here to a certain value, up here to a certain value, down to a certain value. There's really not a great way to do this without actually sketching it in. You could print screen and paste it in your document, maybe. That's another way of doing it. I would be okay with that, to be perfectly honest. So that's another way you could do it if you didn't want to try to describe it in words. And the last thing is to go to the Wave Game tab, which I didn't go to. So back here, Wave Game. So this thing is just, I don't know why they really call it a game, but it's a little exercise where you basically just try to match um, the sine wave that you see on the screen. So every time it gives you a random sine wave. Level 1, you get the harmonic that it's asking for, so that's pretty simple. Level 2, now there are 2 harmonics that are present, but depending on what values they give you, it's pretty obvious which one it's going to be. And as you go through, it gets progressively more complicated. Here, all of them are available, but you still have something that's a pure sine wave. 4, 5 through 6, I guess it's just 4 and 5, are ones that are a sum of only a couple of harmonics. 6 is 3 harmonics, and 8 is 4, and 9, I think, is probably still 4, and 10 is complete free-for-all. So essentially, just spend a little time with this. See how far you can get on your own just by kind of messing around with it some. So say you get to level 5, and without hints, you might not have any clue what's going on here. Something, I don't know, something along these lines. See, even I am not great at this. Oh, that's getting close, so yeah, I'm not going to spend too much more time on this, but maybe that's just the wrong harmonic by a little bit. Let's go to the next one. Oh yeah, there we go. I discovered them, and just a little bit bigger probably there, and so close, but it's still not taking it. Anyway, you get the idea. So I would, yeah, there we go. Got it. Got to level 5, and I probably wouldn't want to go much further personally for the video, but just give it a shot. Tell me how far you get and what you learn by playing with it. This is all pretty simple. As long as you can get the applet to work, you're probably going to get it done in no time flat, because it's really just describing what you see and doing a little bit of playing with this. So yeah, if, as always, when we're dealing with this, if you have questions, feel free to reach out. Email, inbox, and Canvas are both good ways. Since we're not meeting face to face for a while probably, we'll figure out if any other methods are going to be needed as we kind of feel our way through this together. So anyway, hope this helps you get through this one pretty quick. Though I'll continue doing these videos for the upcoming labs, and hopefully it won't be that big of an issue for you guys to be able to work on this on your own. So good luck.